So let's go ahead and get started with lesson 2B. We're working with, once again, change in linear and exponential functions, and this time our focus is on this exponential part. And at the top it says, we have seen that when we look at the output values of a function change at a constant rate, the function is linear, right? Like every time my function goes up or down, it adds or subtracts by that same amount. Now let's look at what happens when the output values change proportionally. So that changing proportionally is what makes it geometric or exponential. When your sequence is geometric, the rate of change will increase or decrease as the value increases. And the easy way to remember this is like which goes with which. Linear goes with arithmetic and geometric goes with exponential. Well, when I'm in geometric form, I look like this, a1 r to the n minus 1. And remember, this is called an exponent. So the way that I remember this is that exponent is in the word exponential. So geometric goes with exponential. And then let's look at how we can go piece by piece and do what it wants us to do. So example 8, use the graph of the sequence shown at the right to complete the table below. So I'm just looking at roughly where these are graphed. So I started up here at 64, then went down to 32. And because we know it's geometric, remember, we know we're going to either multiply or divide. Multiply or divide. So if I'm going down, I know I have to be dividing or multiplying by a fraction. So I can check to see what the common ratio is here by doing front divided by the back. So the second one divided by the first one. So 32 divided by 64 gives me 1/2. So I know I'm multiplying by 1/2 the whole time. So 16, 8, 2, and 1. And that's that common ratio that this is looking for right here of 1/2. And then it says find the common ratio and write the explicit rule. So remember, once again, my AN is going to be my starting term, parentheses R, my ratio to the N minus starting term number. And most of the time when we're given one like this, we're just going to start at term 1 as I highlighted there. So I'm going to write this as A sub n equals 64. My ratio is 1/2 to the n minus 1 because I started my first term. Okay. Now, you can rewrite this. It just depends on what it wants you to write. Like maybe you worked on the packet from yesterday or you worked on the Delta Math and you see some, like right here, it's not always going to have this n minus 1. Okay? It's not always going to have this n minus 1. And part of the reason why that's going to be is they just use exponent rules to rewrite it. So let's do that in part C. So let's use the information from part B to write an exponential function that corresponds with the nth term of the expression. So once again, the function part is just telling me to write it in f of n form. F of n equals exactly what I have above. And then what I'm going to do is use this expression right here to rewrite this. Okay, here's how I do that. Let's break it apart piece by piece. F of n equals 64. And remember, with exponents, when you multiply, you add. So this can be written, n minus 1 can be written as n times that to the negative 1. So whatever it is to the n times whatever it is to the minus 1. So I could write 1/2 to the n times 1/2 to the negative 1. Okay, I just basically break, here in the blue, I break this apart into 2 separate parts. And then I just go to my calculator and multiply these 2 highlighted parts together. And I can just type it in exactly like it is. So 64 parentheses 1/2 to the negative 1 power. And that gives me what I can rewrite it as. So f of n equals 128 to the 1/2 n. So this is the key part right here, breaking apart the n minus 1 to the n and then the -1. Okay, and remember, this is once again because if I did this backwards, so if I went from here to here, it's when I have the same base and I'm multiplying, I add the exponents. So I'd have n plus -1, which gives me n minus 1. So here, given the geometric sequence where A1 is 144 and A3 is 36, state the domain and range. So once again, this is really similar to 2A. If you notice, like what we did on Friday, this is very similar. Same steps. You find your ratio. Second thing, if you find your ratio is fill in table. And then the third thing is find your domain and range. Okay, so when I look at this, the issue is I can't just go from here to here. I can't just divide because I don't have the next term. And I can't really just do this divided by this because I'm skipping over that second term and there's a gap bigger than what I'm used to. So how am I going to do this? Well, we've done this before. You just use our formula. So once again, where do I start? I start at my first term and end up at my third term. And really, if you wanted to, you could use the sixth term, but that's a fraction. I don't want to do that. So I ended up at the third term. So A3 equals A1, R to the, and right here from my exponent, I'm just using whatever the gap is, 3 minus 1. So just plug in what I know, 36 equals 144 R squared. And then just do the algebra to solve this. So 36 divided by 144 is 1/4. And take the square root. So make sure my math's correct here. It is 7:24 in the morning right now. So 1/4, yep, 1/2. Boom. So my ratio is 1/2. So to go from here to here, it's going to multiply by 1/2. It gives me 72, 36, 18, 9, and 9/4. And then my domain and range for a sequence. Now, this is because it's a sequence. Remember, sequences only go up by integers, like from 1 to 2 to 3 to 4 to 5 to 6. There's no 5.5 term. You're just counting where something is in a list in that sequence, so it doesn't make sense to go halfway between something. So my domain is just listing them out. 1, 2, 3, 4, 5, 6, 7. Domain's my x values, and so this is basically my x and this is my y. And my range here is 144, 72, 36, 18, 9, 9/2, and 9/4. And then it wants us to write an exponential function rather, on example 10, where the domain is the same. So basically all I got to do is, if I come up here, I'm just plugging it into this form right here, except because it says function, that tells me I need to be in f of n form. So I'm going to write f of n. I'm looking at my first term here, which is right here. My term 1 is 144. And then I'm going to have parentheses, my ratio, so 1/2. And then I'm going to be to the n minus 1, okay? And then if I want to rewrite that, so remember, usually rewriting it is changing this to just n, okay? So to rewrite this, I'm going to break that apart into 144 times 1/2 n times 1/2 to the -1. And once again, what I'm doing in this step, I'll kind of write it out more distinctly to clarify, is that I'm doing 144 times 1/2 to the -1 power. And that's basically just flipping the fraction and multiplying it. So I'm basically doing 144 times 2, which makes sense, right? Like if I'm going backwards, so in my chart up here, if I wanted to go backwards, instead of multiplying by 1/2, I would want to times 2. And if I wanted to flip it the other way, I divide by 2. That makes sense. So 144 parentheses 1/2 to the -1 power is 288. So f of n equals 288 to the 1/2 n. So those are your function forms. Then here, I'm not going to fill this whole table in just so you can get the notion. The one thing I will say is that the explicit formula for the nth term of the geometric sequence, like you can see here, the main difference from how we've been doing it in this is that a lot of times on these geometric ones, instead of A1 right here, you'll notice that they tend to start at A0. So it just kind of depends. You have to see what you're given, and you have to just plug and chug and make sense of which one it is. And once we do some examples, it'll make more sense, like when it wants A0 and when it doesn't. So this is the same thing as what I was doing before. You can kind of zoom in here and see. It just wants me to fill in the table. So if I look here, this is about 6. So 6, and then that's my second term, so A2. And remember, I can write that as f of 2. This is all talking about the same thing. Term 2, A2, f of 2. And 3 to 6, I'm multiplying by 2. So 12, 24, 48, 96. Just fill in the table. And then this is just A of n. All this table, the main function of this table is to show you that this is doing the same exact thing, okay? So for subscript notation, it's just going to be the normal thing, right? I started, my first term was at 3, so 3, my ratio is 2 to the n minus 1. And then if I wanted to break this apart for my function notation, this is going to be 3 times 2 to the n times 2 to the -1. And then if I type in this, like on this part, you're just doing 3 times 2 to the -1 to rewrite it. So I've got f of n equals, let me type that in my calculator, 3 parentheses 2, 3 parentheses 2 to the -1. That gives me 1.5, and usually you'll see it as a fraction. So math, enter, that's 3/2, 3/2 to the 2n, okay? So that's how you rewrite it. Give the explicit formula for the sequence, starting at 6, and you can tell that this is term 1 from this right here. So my term 1 is 6, or, I mean, if that doesn't make sense to you, you can just plug in. So A1 is 6 times 1/2 to the 1 minus 1, which just gives me 6. So my first term is 6, and then remember, my ratio tells me what I'm multiplying by, so it's times 1/2 every time. So I don't have to do this. I don't have to go A2 is 6 times 1/2 to the 2 minus 1, and type it in my calculator, 1/2, 2 minus 1, that's 3, so half of 6 is 3, okay. I can just multiply by 1/2 if I understand that the ratio is doing that. Like, I'm totally okay if you just want to list your work out like that. So 6, 3 times 1/2 again, 3/2 times 1/2 again, all the way down. Okay, and then it says find the A0 term of the sequence. A0 just means my n is 0 in this case, so A0 equals 6 to the 1/2, the 0 minus 1, which is just 6 times 1/2 to the -1. Type that in my calculator, 6 times 1/2 to the -1, which is 12. So A0 equals 12. And then writing the exponential form of the formula. This exponential form kind of hints to you that it wants it in function form. So exponential denotes that it's in function form. So not 1/2, but rather it is writing it in function form. Like you're not writing it in the sequence form, not a sub n, you're writing it as f of n. Remember, it's just writing exactly what I had before. My first term is 6 to the 1/2 n minus 1. And here's an important note. So when I break this apart, like I do, to write it as just n, so 6 times 1/2 to the n, 1/2 to the -1. And we already found up here that 6 times 1/2 to the -1 gives me 12. So I could write that as f of n equals 12 to the 1/2 n. All we're doing is rewriting it in terms of the 0. Like we're writing it in terms of term 0. So when I rewrite with just n in the exponent, I am, too many humps. I am rewriting the function okay. So when I rewrite with just n in the exponent, I'm rewriting the function for the 0 term. Because right here, a0, it had us find right here, was 12. And notice what's the term in the main front here? 12. Okay, so anytime that I'm getting rid of the -1 in the exponent, all I'm doing is writing it for the a0 term, which makes sense too. Because if I look at my exponent right here, this is basically just saying 12 times 1/2 to the n minus 0, and this would tell me that that is my 0 term. Couple examples here. So Tim released a helium balloon that rose 200 feet in the first minute. In each succeeding minute, the balloon only rises 50% as far, so 1/2 as far as it rose in the previous month. And notice here, okay, this is another time, and you say, well, Mr. Hampton, you said time usually starts at 0. Well, it does. Time is usually talking about 0. But it says, right important here, is that it rose 200 feet in the first minute. So this tells me I'm working with term 1 this time instead of term 0. I'm not starting at 0. I'm starting at term 1. 200 is term 1. So 200 is my term 1 here. Write the general formula A of n that gives you the number of feet risen during the nth minute of the balloon for the time in the air. So A of n equals my start. So 200. And then every minute after that, it goes only half as high. It only goes half as high. Like it goes up, then goes up slowly, goes up slowly, goes up slowly. And then it's going to be 1/2 to the n minus, have my eraser, n minus 1. And then use the formula in part A to find the height of the balloon. It reaches after every 8 minutes. Once again, I could come in here to find A2. I could say A2 equals 200 to the 1/2 to the 2 minus 1 and find that that gives me 100. Or I could just say, okay, my ratio here is 1/2. So to go to each one of these, I'm just going to multiply by 1/2. And that gives me 150 25. Sorry, my brain turned off. So, and then what's the question asking for? It says, use the formula from part A to find the height the balloon reaches after 8 minutes. After 8 minutes. So each one of these portions right here, like so this and this, like all of these are talking about how much it rose. Because each succeeding minute, the balloon only rises 50% as far as it rose. So this is how much higher it's went each time. So to find out how much it's risen total in 8 minutes, I would have to add all these together. So I do 200 plus 100 plus all the way down to the last one, 31.25 plus 1.5625. Add those up together, and you would find that in 8 seconds, the balloon reaches 398.4375 feet. Okay, last one. We have Big Tech Electronics advertises that the monthly payment for the plan of the purchase is best-selling tablet. Buyers pay $50 at the end of the first month, so 50 is term 1. I'm just going to write that down. 50 equals A1. 55 at the end of the second month, so 55 equals A2. 60/50 is A3. So on for 1 year. And it wants to know what will the payments be at the end of the 4th, 6th, and 10th month. Well, to be able to tell that, we need to have our formula to be able to plug into. And one way I know that this is geometric rather than arithmetic, it's exponential versus rather than being linear, is that if I was going to try to subtract these, my common difference would not be the same. So 55 minus 50 is 5, and then 50 minus 55. Just make sure my math's right. So it's 5.5, so it can't be arithmetic. But if I try dividing these out, that I go 55 divided by 50, that gives me 1.1. And then if I do 60/50 divided by 55, 60/50 divided by 55, that also gives me 1.1. So that common ratio tells me that it is arithmetic or exponential. It's month to month, my payment goes, for this tablet, my payment goes up by 10% each month. So I'm multiplying by 1.1 each month. So my general formula is going to be A of n equals, what did I start at here? My term 1 is 50 times 1.1 to the n minus 1. And you can rewrite it if you wish. If you were going to rewrite it, we can go ahead and do that. So we can do f of n equals 50 to the 1.1. Oh, don't know what happened there. 50 to the 1.1 n to the 1.1 to the negative 1. Let's go ahead and put that in our calculator. So I'm doing 50 times 1.1 to the negative 1. And that is basically 45.45. So f of n equals 45.45. And I'm doing a lot of the same steps all at once. So the 1.1 to the n. Okay. And depending on whether you use an or f of n, if you notice in the answer key, it's rounded a little bit differently. Just because you had to round them 45.45, you're not writing 45.454545, it's going to change your answer just slightly. Not too much though, but that's why that is. So to find these, you would just plug in A4 equals 50 to the 1.1, 4 minus 1, and get the A4 is 66.55. A6 you'll get is 80.52 or 80.53, according to which one you use. A10 equals 117.89 or 117.9. Okay. And then how much will the customer pay for the payment plan? You would have to find, like, your total is going to be your first month payment, that 50, plus my second month, plus my third month, all the way up to my last month. So months 1 through 12, and because it says we do this for 1 year right there. So I have to find A1 through A12, which I'll let you do on your own, and you'll get that your total is 1069.21. And then for part C, we already have this written all right here. And then part D, what does this mean in total? Like, I mean, what does the ratio represent, like, in context? Well, my payment is going up, so what that represents, anytime you have like a loan or a pay as you go kind of plan, you're going to have interest. So you are paying 10% interest on your balance each month. Okay. So now transition to the worksheet.